All right, good afternoon, superstars. How are you doing this afternoon? I want to believe you're great. It's time for chemistry class. The day one, we treated organic chemistry. Maybe this is your first time, and I introduced you to the basic aspect of organic chemistry. Basic in the sense that all organic compounds they are derived from alkanes. So we treated alkanes in the first class. The second class we looked at something different, which is another interesting topic. That is redox reactions, where I showed you how to write the equation, ionic equation, and how to balance it. All right. So, and that's another very interesting topic for those of you that were there. And I want to believe that you really learned a lot. Anyway, I need to add that for you to learn really well, please make sure you sign up for the program that is starting next week on Monday. So it's very, very important so that at least you'll be able to enjoy all these benefits. And besides, we are looking at a situation where you're going to have a round figure score. Like I want to achieve with you too. Like I always say, I've produced students with 96, 98, and I want to get 100 in chemistry as well. I want to produce a student that will get 100 over 100 in chemistry. And you could be the one if you do exactly what I tell you to do. So let's start today's class with another interesting topic. And that topic is anytime, any day you see it in JAM questions. And let me show you something, a picture, and see whether you can even guess what the topic is all about. All right, so we are kicking off with this topic today because it's very, very important. When you look at this screen, I want to believe you're seeing a picture of a bauxite. All right, bauxite is all of aluminum. All right, you can see how it looks. It doesn't look good, but look at the product. That is what a particular different processes in chemistry can do. We take something that looks so shitty, all right, something that doesn't look so fine, something that is raw materials. Then we produce something beautiful from it. All right, look at this aluminum product and look at where we got it from. So sometimes we don't do it by just any ordinary process. It takes lots of processes. One of them is electrolysis. And that is why I'm saying that we are going to introduce you to this topic, electrolysis. All right, electrolysis is a very interesting topic, but unfortunately, many students find it very difficult. All right, they say, hey, how will I deal with electrolysis? I want to make it simple for you. All right, but in a deeper understanding of it, please join the class so that at least we'll use all the methods possible how JAMP can ask questions on electrolysis. When you look at electrolysis, let's start from the definitions of electrolysis. All right, electrolysis. All right, because the first thing we're going to do, we're going to be able to define electrolysis. Then after that, we would learn how to explain the principles of electrolysis. Then we'll make some relevant calculations using the first law of electrolysis. This is just a scheme that we are intending to cover in this class. Okay, so what is electrolysis? It sounds that the definition will be easy because of the name, electrolysis. Okay, when you see that sounds like electricity. All right, so that means we are using electricity. Lysis, most of you that are used to biology, you know that that's is like breakdown. All right, so electrolysis is just like using electricity to break down something. And what are we breaking down? We're breaking down ionic compounds. Okay, ionic compounds that can be ionized. Okay, that is what we're breaking down. So we're breaking down ionic compounds, and that is what electrolysis is all about. All right, so how do we make sense out of this? If you break down organic compound, we are trying to produce something from breaking down the ionic compound. So Electrolysis is the breakdown of ionic compound by the passage of electricity through either its aqueous solution or the molten form. That shows that for this electrolysis to work, the electrolyte must be in aqueous form. Okay, must be in aqueous form, all right, or it must be in molten form. Okay, either aqueous form or molten form. Those are the two ways in which electrolyte can work. So let's quickly look at the components in terms of setup of electrolysis. We have to quickly look at this. There are three important things that you need to know when we are discussing electrolysis, and this is very, very important. Okay, this is very, very important. Electrolysis setup, it includes just three main components. Three main components, and I want you to write it. The first one is electrolyte, all right. The second one is electrodes, and the third one is source of direct current. That is like battery, something that is producing electricity. Those are the three important components of it. Okay, electrolytes are the inorganic compounds, or let's say ions that that is decomposing by electrolysis, while electrodes are dipped into the electrolyte, just like you see in the diagram that I'm showing you. Then the electricity powers it. Once you connect the battery, the electrolysis has started. What am I saying? You're going to get this in a bit because we're going to put two or three things together and we'll be able to give examples of how we can understand this electrolysis. All right, let me put it in right perspective. You're just joining us. We are looking at electrolysis today, and I said it's a very important process, although most students find it very difficult, but it's very simple. And we say that when it comes to electrolysis, we are trying to produce a certain substance, okay, by breaking down a compound, which are inorganic compound, and produce something at the electrode. And let's see examples of this, all right, without going deep into the setup. Just understand that we have three important components of the setup. So we want to talk about the principles of electrolysis now. Principle of electrolysis, we have three stages of it, and that is very, very important for you to understand. This is where electrolysis actually starts. So if you're out there that, oh, electrolysis, you've read it in secondary school when you were in year 12, SS3, you possibly had issues with it. Please sit down with me while I explain these principles of electrolysis. All right, it's going to be in three stages. All right, let me quickly take you through the writing. Okay, the first one, when you carry out electrolysis, let's say, for example, we are using electrolysis. Want to electrolysis of sodium chloride, which is aqueous solution. This just means that sodium chloride is a salt, like table salt. We dip it in water. I mean, we dissolve it in water. Then that is our electrolyte. Okay, so that is our electrolyte. Okay, electrolyte. Okay, that is the compound, inorganic compound that will decompose. All right, what can we use this to do? Imagine salt. Salt is very cheap. In fact, it's supposed to be the most expensive substance in our kitchen. If not because we have salt water, rock salt that are just there, just take it, evaporate the water, you get sodium chloride. But there are so much more that we can get from sodium chloride using electrolysis. So, and that is where the application of this electrolysis starts. So the electrolyte is sodium chloride when dissolved in water or when molten. Okay, so I've told you that electrolytes can conduct electricity in two ways. The first one is when it is dissolved in water. That is what we call a pure solution. Okay. Okay. The second one is when it is molten. Okay. I just want to quickly go through this. Those are the two ways that electrolyte can conduct electricity. Sodium chloride in the solid form will not conduct electricity because the ions are not moving. Okay, the ions there responsible for the conduction of electricity can only move when it is dissolved in water. We say aqua. So you can see that's water aqueous, okay? There, or when it is molten, that means when it is melted, all right? So it's better for you to understand that when it is melted, when it is molten. So those are the two ways in which electrolyte can conduct electricity. So what is the first stage of the principle of electrolysis? The first stage is the ions are just distributed, all right? Just like sodium ion is this, chloride ion, they're just everywhere. Okay, nothing is happening, moving randomly. They are not arranged in any particular way. So they are just in the container moving. Okay, so and why are they moving? They have to undergo what is called ionization. So ionization is the first principle first of electrolysis, ionization of the electrolyte. So please let's try that. Ionization of the electrolyte. We're just starting so that you understand and put it in the right perspective. We want to explain the principle of electrolysis. Number one thing you need to know is just like the electrolyte is the one breaking down to give us the product that we're looking for. So, and they can only do that when it is in two forms, aqueous form or in molten form. And I've explained that aqueous form means you dissolve the electrolyte, you dissolve it in water, all right? Or when it is molten, when it is melted, all right? So water is not present in the molten form and it can still conduct electricity that way. So the first thing is the ionization, all right? So let's see how sodium chloride will ionize. That is what the first thing I want to talk about. Okay, sodium chloride is aqueous, so we have sodium chloride. Because it's aqueous solution, we also have water. So sodium chloride will ionize into sodium plus and Cl minus. Why water? Because the ionic substance with water will be H plus and OH minus. Can you see? So if I tell you in the electrolysis of dilute sodium chloride solution, how many ions are there? How many charged particles? You can see that we have 4. Because if it is aqueous solution, water must be present. If it is molten, no water is present. So if it is aqueous, so that shows that the ions that form the inorganic compounds that we're talking about is there. That is ionic compound. Then water, so making it 4 different ions. So these are the ions that will be moving. They just be moving across the system. Nothing is happening to them. They're just enjoying their freedom moving. But immediately you connect the battery, that shows that electrolysis has started. Immediately you connect the battery, the electrolysis has started. They will send something. And what is that? They want to move to their respective poles. You know, I've told you that, let's say this is the container where the electrolysis is taking place. Okay. The electrodes are dipped into electrolyte. Okay, we have a negative electrode here, we have a positive electrode. So a negative electrode is called cathode, okay, while a positive electrode is called anode. Please know that cathode, that is where cations will go. Cations are positively charged ions. Okay, don't get, a lot of students get they get confused around this place. In electrolytic setup, a negatively charged electrode is called the cathode because that's where the cation, that's where they go. Cation and positively charged ion, they go there. All right, so immediately you connect with the battery, okay, that's the source of electricity. Okay, what will happen is that you will see all the positive ions will come to the negative electrodes because like charges they repel, unlike charges they attract. So the positively charged part of it, look at the sodium ions, that's what I'm writing there. So they will just clog around the that. But do you know that we have 4 ions, okay? In there we have sodium ions and we have hydrogen ions. Then we have from Cl minus and OH minus. Okay, these two they are from water, while these two they're from the inorganic compounds that we're talking about. So what will happen is we have these positive ions. both of them will go to negative electrodes. Remember, this is the second stage of the principle. The first stage is ionization, they will split into ions. The second stage is once you connect the source of electricity, let's say you connect the battery, the electrolysis will start. The positively charged ions will migrate to the negative electrode. So you're going to see hydrogen here too. Both are distributed along this place. So the negatively charged ions, Cl minus and OH minus, we also do the same around here. Okay, so OH minus, Cl minus, they are close. So that is the second one, which is the migration or movement of ions. Okay, I hope you're getting this. So it's very, very important for you to do that. Okay, make sure you understand. The first one is they just simply ionize. The second one is they move to their respective poles. How will you know where they will go? The possibly charged part of the system will go to the negative electrode, which is cathode, while the negatively charged ions will go to the negative electrode, the positive electrodes. Okay, because unlike charges, they attract. Right. So the third one is now when these two are competing, which of them will be produced? That means which of them will be our product of this electrolysis, because the product the intention of electrolysis is to make sure that we produce something, and what we are producing will depend on the substance, that is electrolyte we've started with. So the first principle is the ionization of the electrolyte, okay, which is like breaking down into ions. All right, the second one is movement of ions to their respective poles. The positively charged ions will go to the negative electrode, while the negatively charged ion will go to the positive electrodes. Now, the third one, you will see that two ions are competing. All right, two ions, two charged species, they are competing. All right, that means at the cathode, we can just tell you at the cathode, what are the stuff competing? We have hydrogen ion and sodium ion competing. At the anode, which is a positively charged ion, we have Cl minus and OH minus competing. So one of them will be preferentially discharged. That means one of these two ions will come out of the solution as our product, and which one will stay. All right. So that depends on three factors, and those factors we're going to explore it really deep, maybe starting from next week. But the point is, I'm going to give you an example of the real electrolysis, then we now work it out how you're going to get the product from it. Okay, so I'm saying that the first one is the ionization, the second one is the movement of ions to their respective pole, the third one will now be preferential discharge. Why do we call it preferential discharge? That means one will stay in the solution while one will be discharged. That means one would be produced as our product. And I said this number three now leads us to three factors, because which of them will stay in the solution, which of them will come out. So it depends on three factors. The first one is position of ions in the electrochemical series. That means if hydrogen is going to be our product instead of sodium, so what are the factors that will come into play to make sure that hydrogen is the one that will be produced? So that is what we're talking about. So preferential discharge of ions, all right, depends on the three factors. So the first one is the position of ions in the electrochemical series. Let me just show you the cations electrochemical series. So you see the cations and the anions involved. Okay, so these are the this is electrochemical series. Electrochemical series helps us to actually see when two ions are competing at the electrolyte, which of them will be preferentially discharged and which of them will remain in solution. I believe that I've been able to put this in the right perspective, so that at least you'll be able to understand this. Now, look at this. The first one, ionization takes place. The second one, the ions migrate to their respective poles, but they just find out that somebody is competing with them. All right. So which of them wants to jump out and which of them want to remain in solution? The one that jumps out, we say that is preferentially discharged, and that is our product of the electrolysis at that particular electrode. So when two ions are competing for cations, the less electropositive ion is the one that will be preferentially discharged. All right. That means that one is less reactive. So it's kicked out of the system. Look at the way these guys are arranged from potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper. Okay. So this arrangement, you must know it because we call it electrochemical series for cations. You must know it. We have a lot of stuff that you can use. You can saying like this popular scientist can make a zoo in the low humid countryside most satisfactorily good. Popular, that is like potassium, that is the first one. Scientist, that is sodium, can make, that's magnesium, a zoo, that is aluminum and zinc, in that is iron, that is tin. Tin, this the symbol is SN. So they are arranged this way. Okay, there are a lot of stuff that we'll be learning, and some people can rap about it. A lot of things you can do with it. All right, that you can make you to remember this because they are not going to give it to you in the exam. You must know the electrochemical series, how these ions are arranged. But my point here is very simple. What are we going to do here? We just want to make sure that we know if two ions are competing, which one will be preferentially discharged. Now, for the example we are treating, we are talking about sodium ion is competing with hydrogen ion. Look at where the sodium ion is. Let me circle it so that I can see. And look at hydrogen ion. Okay. So when two ions are competing, I hope you can see this clearly. The ion down in this arrangement, that means the one that is less reactive, the one that is below will be preferentially discharged. That is just the principle, okay? Because it's less reactive. It's like the more reactive will displace it and kick it out of the system. Now, because the more reactive one is at the top, it's like the boss, just like kick you out. Please don't stay in the same compartment with me. That is what sodium will tell hydrogen because, of course, I'm more reactive than you. Get out of this situation, leave the house for me. I'm enjoying the electricity and all the things that is happening here. So that's exactly what happened. So if you look at the anions, these ones are negatively charged. Okay, the way they are arranged, you can see this is the most electronegative element even in the periodic table. This look at this. You can easily remember by this. Those four that I just ticked, they are in the periodic table in group 7 elements. Just put SO4 and NO3 in between F and Cl. Okay, then OH is the last one. So the way it's arranged, whenever two ions are competing, okay, the one that will be preferred discharged is also the one below here, the way it is arranged. Okay, that will be the less electronegative species. Okay, so in this case, we are competing NaCl. Okay, so Cl minus and OH minus are competing. So that shows that OH minus will be preferentially discharged. So what does that mean? Okay, it means that you're now going to write the equation at the electrode. Okay, so let's see how we're going to do that now. Okay, before we go there, let me clean this so we can use this space. I thought I left enough space for that. All right, so you know what I want to do now? I want to now write the equation of this at different electrode. Okay, so let me pick another free stuff. Just hold on, please. Just hold on. Okay, so I want to write the equation of of what is happening at the. I'm picking another whiteboard. Okay, so at the cathode, I said that sodium at the cathode, sodium and at the cathode. Uh, just hold on, please. At the cathode, sodium and hydrogen are competing. sodium and sodium. Oh, just hold on, please. Okay, sodium and hydrogen, they are competing at the cathode. So which of them will preferentially discharged is going to be hydrogen, because hydrogen is less reactive, okay, than sodium. Okay, I'm trying to write here. So hydrogen will be preferentially discharged. Okay, just hold on, please. Having a little itch with my writing pad. All right, so okay, um, just hold on, please. All right, I have a little challenge with my. Let me just quickly disconnect and plug properly. So if that will make it work, all right. Um, Ademola, please just help me plug this properly while I explain the principle. Go over there. All right, so I have a challenge with the writing. It's not active. All right, just hold on, please. All right, I think it should. Okay, so just hold on. Let's see. It's not writing. All right. So what I want to write the equation of how hydrogen will be preferentially discharged. Maybe, get me another pad over there. Maybe I should plug it. This is not um, it's not working. I don't know. It's not writing. All right. Okay, just hold on, please. I'm trying to write the equation, show you how to write the equation correctly of when hydrogen is preferentially discharged. All right, when we compare it with the sodium in the this during this electrolysis. Okay, I just want it to. It's not. It's no longer active. All right, so just hold on. Get me another pen. Just hold on. Okay. All right. I'm trying to change my pad. I'm having, there's no much we can do. I don't just want to explain. I want you to see the way the equation will go whenever hydrogen is discharged uh, in at the electrode. So, and I really want to show you that. So just please be patient with me. Let me sort this writing pad so that it can be. Just hold on, please. We're trying to fix this. Okay, let me see if I can try it manually. All right. Or is the network? It's not. Okay, let's see. Okay, let me refresh this. I don't know. Okay, it's kind of network. I think it's back now. Okay, it's back now. Let's see. I fixed it. Yeah. Okay, it's okay now. So sorry for that. Sometimes you can't predict what happens. Okay. So all right. So let's go on with what happens at the cathode. Okay. I said at the cathode we have sodium ions and hydrogen competing, and we've said that hydrogen ions will be partially discharged. So we're writing equation for hydrogen ions. Okay. We want to write H like this, right? Because we are starting from hydrogen ion, you just have to make it neutral, all right? And I believe that you've seen this clearly now. Okay, we'll make it neutral. So look at this. We have plus one here, we have zero here. So that shows that we're going to add electron to a particular place. So where are we adding electron to make sure that it's easy? Okay, if I add electron to this side, I'm just showing you. So the total charge at the product will be minus one. This will be plus one. So it's still not the same stuff. Okay. So that is why we have to write it this way. First of all, you write H plus is preferentially discharged as neutral H. Can you see that? Then you add electron to this side. Okay, because hydrogen occurs as H2. That is the diatomic molecule. So we are going to write this equation again. So if you add it together, you're going to have 2H plus 2 electron will give you H2. So this reaction occurs at the cathode, and hydrogen gas will be the product of that particular at the cathode. So let's see what happens at the anode, and that is where you will see another stuff there. So at the anode, we have Cl minus and OH minus competing. Okay, when these two are competing, we've told you that the one below, which is less electronegative, will be the one that will be potentially discharged. So that shows that we have this guy OH minus. So this is very simple. When OH minus is the one that is discharged, we're going to write it in a neutral form as well. All right. So that is the first one. Whenever OH minus is discharged, that is the oxygen gas that wants to be produced. So and you must understand this. Whenever OH minus is preferentially discharged, it means that the oxygen gas is going to be the one that will be liberated. So how would are we going to form the oxygen gas from here? So OH minus to OH, all right? So this is minus one and this is zero, all right? This is minus one, this is zero. So that shows that we're adding electron to this side. Okay, so that this one will be minus one too. So the charge will be balanced. So the first single equation is that OH minus will give us OH plus E minus. But so many OH minus are in that process. So many OH minus, they are in this system. So we're going to write the same equation again. You will understand what I'm trying to do now. Okay, we're going to write the same equation again, and we'll see how we're going to do that. Okay, so let's see OH minus again will give you OH plus electron. All right, so if you look at this, let me pick the red pen so that you can get this clearly. If you look at this, what is this part that you're seeing there? That is H2O, right? So that shows that you have two OH minus will form H2O plus O plus two electrons. All right. Remember I said that there are millions of OH minus that are there. Millions, OH minus, Cl minus, they are just moving several million forms. Okay. So that means two OH minus will produce one oxygen atom. I want to produce just oxygen is O2. So if 2OH produces 1O, that shows that it's 4OH minus. So I'm writing another 2H minus. So many students find this very difficult, but it's very, very simple. So let me just show you this. So when you add these two OH minus together, so you don't cram this, because if you cram it, you will forget it. So 4OH minus will give you 2H2O plus O2 plus 4 electrons. Okay, so this is the equation now at the anode. And I want to believe that you got how I just wrote this now. The first thing is to convert all the charges into neutral molecule and use electron to balance it. So you can see that two of it will produce one O, but oxygen exists as O2. So that shows that 4H minus will produce O2. So the equation at the anode, which is anodic half equation, is this, which is the main guy there that we are producing is oxygen gas. Then the other one, which is the cathodic half equation, will produce the main gas as hydrogen. Therefore, electrolysis of sodium chloride will produce hydrogen gas at the cathode and oxygen gas at the anode. All right. So I believe that this is just the first example. We're going to have so many other examples next week. All right. So, and please, you have to do that. And it's very, very important to know that. All right. So let's quickly use some this remaining time to do some calculations as regards the electrolysis. This is the principle just to show you that it's actually very simple. All right. If it's still difficult for you in a way, don't worry. All right. The little time we wasted while we're trying to fix the writing pad, it caused a lot of problems. So, and that is the reason why we have lost some time. I would have done another example till you find that, oh, this is actually very easy. Of course, just understand that the ionization will take place first, then migration of ions, then preferential discharge, which depends on three factors. The first one is the position of ion in the electrochemical series. The second one can be concentration of ions and the nature of electrodes. Those are the three factors that will determine what comes out, what we get as the product of electrolysis. So let's move straight to the calculation aspect, which is the first Faraday's law of electrolysis. Okay, first Faraday's law of electrolysis. So electrolysis, you have just two laws as regards your chemistry and syllabus. So we're going to talk about the first law and quickly apply it in 10 minutes, and you see how simple it is. I'm going to give you a formula that works wonders. It solves almost all your problems in the calculation of electrolysis. And you're going to see it with example with JAMB in this next 10 minutes that we're going to talk about this. And I want to believe that we are ready now to please let's get our pen and calculator ready so that we can quickly do that. Okay, what is Faraday's first law of electrolysis talking about? You know, I also have second law, but we're going to treat only first law now. Uh, in electrolysis, you are trying to produce something. So, and what quantity of it are you going to produce? And that is what we mean when we're talking about the laws of electrolysis. They're just addressing the quantitative aspect of it. That is, if I want to say it in a layman's language, just the calculation. How much of it can we get when we are talking about electrolysis? So the first law says that the mass of an element or a substance liberated during electrolysis, the mass of a substance during electrolysis is directly proportional to the quantity of electricity passing through it. What does that tell you? The mass that we're going to get at the end of the day, electrolysis, it depends on the quantity of electricity passing through it. All right. So this same mass is the same thing as quantity of electricity is the same thing as IT. Okay. Some of you in mathematics, you know that when you have the proportionality, when it becomes equality sign, we have the constant proportionality, we call electrochemical equivalence. Okay. So this is the mathematical expression of the first law. All right. All right. That is the mass of an element liberated is directly proportional to the quantity of electricity passing through it. All right. So if we want to now use this, how do we arrive at that? So please write this mass deposited equals to quantity of electricity times the relative atomic mass over the charge of the ion, that's represented by Q times Faraday. All right. The quantity of electricity, that is the unit is in coulombs. Okay. So coulombs is like this Faraday as well. So that means this Q shows that what quantity of electricity is used to deposit this Faraday. Let me now just try to play with this. If I divide M by relative atomic mass, I get mole. That is M divided by relative atomic mass. Okay, is going to be Q over the small q, that is the charge over Faraday. Okay, so mass over molar mass, you already know, is mole equals to Q over Q small q times F. Now, what is this? Please, let's see how we're going to apply this formula and see how it applies to this first law of electricity. It's just telling us that if you increase the quantity of electricity, okay, is it going to be a function of time, the ampere, the current that passes through it, and also the time, the length of time we use to pass the current. All right, that's why Q is the product of IT. In this first one, you can see the Q. So our Q equals to current times time. So it's very, very important to know that. Why the current is in ampere and time is in seconds. So this is the formula that we're going to be using, and it's going to work a lot of wonders for us. Remember, in the main class, we're going to explain the main component in such a way that everyone seated there, you will grab it in sense that every of these, we're going to give example, like maybe like 10 different examples addressing one different thing at a time. And that is when the full understanding comes, okay? Because there are different ways to it that will bring out the meaning of how this particular formula was derived. So it's very important for you to know that. But for now, just make sure that you keep this formula till that time. We'll be meeting starting from next week. M equals Q. What is Q? Q is the quantity of electricity, which is the product of the current and time. All right, relative atomic mass of the element that we're talking about and the charge on the element. Okay, so we're going to do that and use it to solve some questions now. So let's go and see some past questions and see how we're going to use this formula to do that. Okay, so these are the real jam questions. They say, how many coulombs of electricity are passed through a solution allowed to run for 1 hour? Remember, I said that we are going to be talking about time. The time has to be in second. Okay, so look at this. This is a true jam question, 986, number 16. I just want to know that. Okay, how many coulombs of electricity are passed? Please zoom it from your own end if you feel like the question is a bit small. I just created this space so that at least I can work it there. So how many coulombs of electricity are passed through a solution in which 6.5 amperes are allowed to run, all right, for 1 hour? So the quantity of electricity, I said the quantity of electricity equals IT, I times T. Okay, so this I is the current, which is in amperes, and time is in seconds. Please take note, we must convert our time to seconds. So the current there is 6.5 times the time is 1 hour. 1 hour is 60 minutes, all right? If you want to convert 60 minutes to second, you multiply again by 60. So it shows that 1 hour is like 60 times 60 seconds, 3,600. Now let's multiply this, and I want somebody to drop the answer. Okay, so I will see if you are actually following. So current times 60 times 60. What is that? 6.5 times 60 times 60. Somebody should drop the answer. Let's see whether we're going to figure out the answer from this jam question. All right. Quantity of electricity equals current times time. So 6.5 times 60 times 60. What is that? So, all right. So please let's drop it. Let's drop it. All right. 2, 3. Thank you, Uchechukwu Henry. So that is 2, 3, 400. All right. The decimal is there. But the problem is they presented this answer in that jam question in standard form. So we're going to take this back. 1, 2, 3, 4. So that is 2.34 times 10 raised to the power 4. Okay, if you're moving backwards like that from the decimal, it's plus. So 2.34 times 10 raised to the power 4. So the answer that here is D. So it can be that simple. And that is what I told you, that you should write this formula. Q is equals to IT. So let's see the second one, question 2. The mass of copper deposited when a current of 2 amperes passed through a solution of copper salt for 60 minutes. All right. We are to calculate the mass of copper also deposited here. Okay. The mass of copper deposited. Okay. We just have a few minutes to go, and I have to solve this using the formula. So write M equals Q, that is current times time, times relative atomic mass of the metal involved over the charge times Faraday. Okay, so the quantity there is IT, that is current. Look at this, times time. Now this is 60 minutes. So if you want to convert it to 6 seconds, look at what I'm doing. You multiply that. What is relative atomic mass of copper? Is given as 64 divided by, now what is the charge of copper? Okay, most copper salts are +2, like copper sulfate, all those are ionic compounds. So we have to know that in the real the explanation of electrolysis, when we are treating it, I'm going to give you metals and their charges, and you see it in their compounds. So the copper, usually say copper 2 plus, okay, just like in copper sulfate. With your syllabus, copper sulfate solution is one of the examples that we have to deal with. All right, Esther has dropped the answer. He said D. Let's find out whether it's actually D, or maybe you mean the first question. So the charge on copper is 2 times Faraday is 96,500. Let's multiply that and see whether we'll get the answer. Okay, quantity is IT, time in second, times 64, 2 times 96,500. Let's see. Have you got your answer? Let somebody drop that. So the answer of this one is not D. Maybe you're referring to the first one. Oh, 2.3875 or so. So we'll stop here. So that makes it 2.39. Okay. It's that simple. Okay. So this is how we're going to be applying this formula. But mind you, in the real class, we're going to start with the definition of electrolysis. We're going to explain the principle, give you different examples, and at the same time, we will now give you the different metal ions that we use based on your syllabus of JAM. All right. After that, we'll give you different questions from past questions that explains why we use what at one particular place. So what I'm going to do is I'm going to just tell you to screenshot this two questions. Okay, this is the next one. Two questions. I want to see what you're going to do here. All right, let's screenshot this as part of the assignment. Please drop the answer on any of my social media platforms, usually maybe Instagram, even on TikTok, okay, X. Please make sure DrJan knows chemistry. Make sure you drop your answer there. I'm giving you question 3. These are the real JAM question, 2015 number 49. So please let's screenshot this because we have just 1 minute left, which I'm going to round off the class now. So the second one, screenshot this. This last one, screenshot this, please. Right, screenshot that. Okay, so these are the two assignment I'm going to give you. Remember, explore the formula that I have given you. Q times relative atomic mass over the charge times Faraday. Okay, use this formula and see how it helps you to solve a lot of problems. All right, so I want to believe that you learned something in today's class as well. Please, if you want to enjoy more of the class, please, you better just register, sign up on tutorial.com/UTME. Go to all our social media platforms to read more information on how you can join all the staff tutors. We are fully ready and we are committed, and as teachers want to achieve as well. So thank you very much and see you next time. Bye for now.